exponential equation. So I'm going to ask myself this: can I easily fix it so the left and right side are written in terms of the same base? For this problem, the answer is no. 3 is a prime number, so it's going to be 3 or bust, and 8 is not a power of 3. When we cannot easily fix it so the left and right side are written in terms of the same base, then we're going to take the logarithm of each side. Should we take the logarithm of base 3, take the logarithm of base 8? It's fine. You can do whatever you want, but we don't have a log base 3 key here. We don't have a log base 8 key here. So the recommendation is to stick with the common logarithm or the natural logarithm. You'll get the same answer, I promise. We'll just go with the common logarithm, okay? So take the logarithm of each side, base 10, logarithm of the left, logarithm of the right. Remember, when the base of the log is 10, there's no need to write it. It's understood that if it's not there, then it's base 10. What are we going to do? We're going to go ahead, use the, once again, where am I? We're going to go ahead, use the power rule of logarithms to bring the exponent down. Okay, let's go ahead, use the power rule of logarithms to bring the exponent down. And that will leave us with the exponent of negative x plus 5 times the leftover logarithm, okay, times the log of 3. Now, I understand myself. I know that I meant to write exponent times log 3, but check it out. The world cannot read my mind, okay? The world only sees that I'm not multiplying the entire negative x plus 5 by log 3. I'm looking at what's before and after the raised dot. The only thing that's before the raised dot is the 5, and the things that after it is the log 3. So what I want to get at, that the world sees that you're only multiplying the log 3 by 5. Maybe I make this a bigger deal than needed, but you know, the little things quickly add up. So be careful with your notation. Let's go ahead and wrap up this 2-term expression. Okay, so we bring the exponent down and then multiply it by the leftover log, namely log 3 equals the right side, log 8. Okay, what are we going to do? It's really a personal choice because we all think a little bit different. So our solutions may differ, but signs cancel and we'll get the same answer. For me, I'm in the habit of clearing the grouping symbol. So let's go ahead and distribute. Log 3 times the first thing that we see will give us negative x log 3. Okay, one product down, one more to go. Log 3 times 5 is just log 3 times 5, but we'll put the 5 before. 5 times log 3 equals log 8. Okay, fantastic. So let's go ahead and work our magic to isolate the variable term. So if you're not with the x, you gotta go. To undo an addition, let's go ahead and subtract. So we'll put minus 5 log 3 to both sides. And that will leave us with negative x log 3 is equal to whatever you want on the right. You can put log 8 first or the minus 5 log 3 first. It's a personal choice. For me, it's easier to start on a positive note. So I'm going to put the log 8 first. So that will give us log 8 minus 5 log 3. Fantastic. So we've isolated the variable term, but now we want to isolate the variable itself. To get rid of the times log 3, we're going to go ahead divide both sides by log 3. But that will leave us with a negative sign. So let's just go ahead divide both sides by negative log 3. After we divide both sides by a negative, quotient of two negative things will give us a positive thing, and the quotient of log 3 in itself will give us 1. So that will leave us with the x isolated, and x equals exactly log 8 minus 5 log 3 all over negative log 3. Okay. Now, if you took a slightly different approach to solving the equation, the expression will look a little bit different, but I promise that if we didn't make an algebra mistake, they will simplify to the same exact thing. So that is the exact answer. The direction